In this video, we're going to be adding and subtracting a few rational expressions. Now, before we could add or subtract any type of rational expressions, we need to make sure that the denominators are the same. In this problem, they're not the same. So what I'm going to do is take this 5m cubed here, and I'm going to multiply this rational expression by 5m cubed, the numerator and the denominator. This is one of the first steps to finding the common denominator. Now, if you're asking, well, why can we just multiply the top part and the bottom part by a certain value? Well, if you look at 5m cubed and you think of it as a fraction where 5m cubed is in the denominator as well, this is just equal to 1, right? If we had 3 over 3, that's equal to 1. So really, I'm not changing the value of this rational expression. I'm multiplying it by 1, and it's just going to change the way it looks. Now I'm going to take the denominator of the other rational expression, so this one right here, and end up multiplying this rational expression's numerator and denominator by it in the same way that we just did over here. Now I have two new parts. I have this part on the left side, and then I'm subtracting this part on the right side. But as you can see, I'm going to have common denominators now. So now I could actually multiply together these two parts in the numerator. So 5 times 5 is 25, m cubed times m is m to the fourth, and then over here I have subtraction, and 3 times 2 is 6, and m times m squared is m cubed, and then in the denominator I just have a 10m to the fifth. All I did was multiply these two together, and I only write my denominator one time because of this situation right here. Imagine if we had 1/4 plus, let's say, 2/4. How many fourths would we have? 3/4, right? We're not adding together 4 and 4 to give us 8. We're keeping the denominator the same, and we're just adding the numerator. That's the same thing we're doing here. We want to keep 5 times 2 and then m cubed times m squared together, which is 10m to the fifth. We only write it one time. Now, we could almost say that this is our final answer because these two terms up here are not like terms because we have m to the fourth and an m cubed, so we can't combine them. However, we can reduce all these terms by a value. That value is going to be m to the third power because each one of them has it. So here's what happened when I divide all these terms by an m cubed. M to the fourth divided by m cubed is just an m. This divided by this right here is just 1, and then 5 minus 3 is 2, so we're left with an m squared here. So now I could rewrite my rational expression. There we go. And this is with the idea that my m down here cannot equal 0, because if you plug in a 0 for m, you're going to have a 0 in the denominator overall, which can't happen. So this is going to be our total complete final answer. The second question is done really similar. We're going to take our denominator here and we multiply the top and bottom part by this binomial. Then we take this denominator here and I multiply top and bottom by that as well. So now I have my two new parts. I have this part on the left side, and then we're adding in this part on the right side. So what I'm going to do next in my next step is take my 6x and I have to multiply it by these two terms. So I'm going to have to distribute 6x times this one and then 6x times this one right here. And I do the same thing here, 6x times this and 6x times that. So here's my answer when all of these terms are distributed out. 6x times x is 6x squared, and then 6x times 2 is 12x. We did the same thing over here. We got this binomial. Now we could actually add together those two numerators, and that just means that I'm going to combine all the like terms. So here's going to be the result of that. What we did was take 6x squared and add it to this 6x squared. We got 12x squared, and then we had 12x here, and we're adding a negative 24x. When you combine those two terms, we have a minus 12x. And then of course we just rewrite the denominator. Now after we've combined these two original rational expressions, we want to see if we could reduce anything. Well, there's no number or value or anything like that that we could reduce the top part and the bottom part by, but I do have two binomial factors down here, so sometimes you could actually cancel a binomial factor from the numerator and the denominator. In this case, we have a 12x squared minus 12x. Of course that doesn't cancel anything or cancel out with anything in the bottom, but you can factor this up here. So let's try to do that. Here's that factored form over here, and what I did was divide out or factor out the greatest common factor, which is a 12x. As you can see though, nothing cancels out with anything in the numerator and denominator. We don't have any like factors, so we're left with this is our final answer. Or you could have even written it like this. Either one of these forms would work in our situation, but you do have to write the fact that x cannot equal a -2 or x cannot equal a +4, because if you plug in either one of these numbers in the variables in the denominator, we're going to be getting a 0, which cannot happen. Okay, the last rational expression, we have subtraction, and we do it the exact same way as the other two. We're going to take this part right here and multiply the numerator and the denominator by it. Then we take this denominator here and multiply this numerator and the denominator by it as well. So now I have my brand new part on the left and then my brand new part on the right. And before we actually go ahead and do the subtraction, we want to take this number here and distribute it with all three of these terms. So now I'm left with these two huge rational expressions, because 3x times x squared gives us 3x cubed. 3x times 12x is going to be a minus 36x squared, and 3x times 36 is 108x. And then all we had to do here, it was a little bit easier. We take 5 and multiply by 2x squared. We didn't have to do any distribution because there was no addition or subtraction between any terms. So here's where we're left off. Now what we're going to do is take the actual subtraction of 10x squared from this trinomial. And when I rewrite everything, I'm going to actually factor this trinomial down in the denominator as well, and I'll explain that in a second. So when I subtracted 10x squared from this part, it was taken away from this term because this was also an x squared term. So we were left with a minus 46x squared, and then we just brought down the 3x cubed and the 108 times x. But I did factor this trinomial right here, and I rewrote it down here. And the reason I do that is because I want to see what my excluded values are going to be. So like what values can I not plug in for x that would make my denominator 0. If we were just looking at the trinomial here, that would be harder to figure out, but by factoring it, it makes it a little bit easier. And who knows, maybe I could take a binomial that ends up coming up here and cancel it out with one of these binomials. So there's a few different reasons to do that. Now at this point we have to ask ourselves, is there anything that could reduce or cancel out or anything like that? And as you can see, each one of these three terms in the top part does have an x. And do any of our parts down here have an x? Yeah, it's this x squared. So you could reduce by an x. So after I reduce everything by an x, I'm left with this rational expression. The trinomial that we're left with right here isn't going to be factorable to where we could cancel out any of these binomials down here. So this is going to be my final rational expression, and we could list the values that x cannot equal as a 0 for that x, and then we cannot plug in a positive 6 there either. So x cannot equal 0 or 6 because that would give us zeros in the denominator.